Uh, Hello everyone. Hello everyone. Today we'll discuss on design of tension members. So today we'll discuss what are the various steps involved in the design of tension members. Your first step is to in design of tension member. Your first step is to calculate your first step is to calculate the grass area required. So how to calculate grass area required? So that will be taken as equals to factor load into gamma m naught divided by Fy, gamma m naught divided by Fy. So factor load usually given in the problems. Gamma m naught is partial safety factors and Fy is the yield stress. So by using these formulas, you can easily find out the what is the grass area required. So please remember, so in first step we need to calculate what is the grass area required. So here so whatever whatever the area you will get, it should be increased by 25 to 30% approximately. Please remember, so whatever the area you will get, it should be multiplied with it should be increased by 25 to 30% approximately. Means whatever the area you will get, it should be multiplied with the 1.252, so area into 1.3 times. So please remember, very important steps. So after by using this formula, you will calculate what is the grass area required. Then next step is to increase the area by 25 to 30% approximately. Means whatever the area you will get, it should be multiplied with 1.25 times or 1.3 times. So please remember these steps. Then then you select the after that, after calculating the areas, after increase by 1.25 times or 1.3 times, then after calculating the areas, then you select the suitable sections required from the steel table. So very important, we need to select what are the suitable sections required from the steel tables. Then your second step is connections. So your second step is to connections. So based on what type of connections you are providing, based on the what type of connections you are providing, so you need to calculate the number of the bolts. If you are giving bolted connections, then you need to calculate what is the number of the bolts required for the connections. So then, or if you are giving welded connections, then you need to calculate what is the length of the weld required. So if you are calculating, or if you are giving bolted connections, then you need to calculate what is the number of the bolts. How to calculate number of the bolt? So it will be force divided by the bolt values. Force divided by the bolt values. So force means the factored load divided by the bolt value. So we need to calculate the bolt values. So then it will give the number of the bolts. Then, or if you are giving welded connections, then you need to calculate what is the length of the weld. L1 equals L1 or L1 and L2 or L total length of the weld required. We need to calculate. Then your third step is to we need to check for the failures. Please remember guys, tension member subjected to a three type of failures. Tension member subjected to a three type of failures. So tension member subjected to a three type of failure. It may fail due to yielding, it may fail due to ruptures, and it may fail due to the black shear. So that we need to check. So then your third step is to calculate the third step is to check for the failures. So what are the failures? Failure due to yielding, failure due to ruptures, and failure due to black shears. So now first you need to let's take this one, failure due to yielding. Means you already know that what is the formula for yield strength. TDG equals to AZ into Fy divided by gamma m naught. It's there in page number 32. So it should be greater than whatever you will calculate TDG. It should be greater than the factored load. Please remember this. First you need to check for the failures due to yielding. So that will be given by TDG equals to AZ into Fy divided by gamma m naught. Here AZ is the cross section areas and Fy is the yield stress and FL is the factor load. Gamma m naught is the partial safety factors. You already know this. Partial safety factors. Then your second Then you need to check for then you need to check for, guys please, then you need to check for failure due to ruptures. So is there in page number 33, sorry, is there in page number 33. You can go through that. So this is what failure due to ruptures for angles. This formula what I shown here, this is failure of failure due to ruptures for angles. So that will usually given by TDN. This is failure due to ruptures. It is given by 0.9 into ANC Fu by gamma ml plus beta into Az0 into Fi by gamma m0. It should be greater than the factored load. Is there in page number 33. So what is your second step? So you need to check for failure due to ruptures. So what is the failure due to rupture formulas? This is the formulas is given here. So here what is the beta? Beta is what? Beta equals to 1.4 minus 0.076 W by T into Fi by Fu and Bs by Lc. That should be lesser than or equals to Fe into gamma m0 by Fi into gamma ml, and that should be greater than 0.7. So this is how we need to calculate beta values. So here you can check here we are using the betas in this formula. So by using this formulas I can calculate what is your betas. Okay, so here we have some here you can see we have several notations we are using: ANC or Az0 and W and LC and BC. What are all those things? Here I clearly will explain what does that means. So what does that mean? So over here you can take one by one. Az0, what do you mean by Az0? Here we are using the in this formula we are using the Az0. What do you mean by that Az0? Az0 nothing but Az0 nothing but the gross area of outstanding leg. So let us take this example. So this is a gusset plate and this is the angle connected to the gusset plates. So guys please, the leg which is connected to the gusset plate, that is called connecting leg, and other leg is called outstanding leg. So without connections, that leg is called outstanding leg. In angles, the leg which is connected, that is called connected leg, and this is another one is called outstanding leg. So and this is what here Az0 equals to what? Gross area of outstanding leg. So that is gross area of outstanding leg, means this is the outstanding leg. So that is gross area you need to calculate. How to calculate? Let us say this is B, length of the outstanding length, B minus T by 2. So we need to take half of this one, guys please. You need to take exactly at the center. To if you are calculating effective gross areas, you need to take exactly at the half. So B minus T by 2 into T. Similarly we can calculate what is the net area of connected leg. The ANC means net area of connected leg. How to calculate this net area of connected leg? That equals to A means A is the length of the connected leg, minus D0 means we need to deduct the bolt hole, dia of the bolt hole, we need to D0. You need to deduct the dia bolt hole, minus T by 2. I already said you we need to take exactly the half. Here to here, I draw the center line here, here to here. So here to here, that is T by 2 into T. T by 2 into T. So guys please remember how to calculate net area of connected leg. A total length. So A minus D0, we need to deduct the bolt hole, minus we need to take half of that one. So half of this leg, so half of that one into T. This is how we need to calculate gross Az0 and ANC. Similarly here we are using the terminologies. So here you can see BS. What is that BS means? BS means shear lag width. How to calculate the shear lag width? It is there in page number 33. Please go through the IS codes. Here they clearly mention. So BS equals to what? W plus BS equals to W plus WL minus T. What is W? W is the length of outstanding length plus WL. WL is the distance from the here to where you are connected the bolt, from bottom to or bottom of this connected leg to where you connected the first bolting, and so that is length WL. The WL minus T is the thickness. So this is for bolted connections. For bolted connections we need to use this formula. Is there in IS code, guys? Please refer. So I am just explaining the terminologies what you will use. Over here BS, once again if you are giving welded connections, BS is taken as W. W means length of the outstanding leg. And here we can see another terminologies we are using LC. Here we are using LC. What do you mean by that? LC is the distance between outermost bolts. So let us take this example, like this one angle is connected to the gusset plates. So here we provided with the 3 number of the bolts. So this is first bolt and this is last bolt. So distance between these 2 bolts means outermost first bolt and last bolt, that is taken as LC. LC, please remember, first distance between first bolt to last bolt, that is taken as LC, means the distance between the outermost bolts. Here if we are giving a welded connections, we need to take the average of the weld length. So we need to take average of the length of the weld. Please remember, we need to take average of the length of the weld. Please remember this, guys, very important. How to calculate LC. If you are giving bolted connections, distance between the outermost means distance between first bolt to last bolts. So if you are giving welded connection, it should be taken as average of the weld length. So that's how you need to check for the failure due to rupture. So whatever TDN, it should be greater than the factored load. This is we need to remember. So this formula is given in page number 33. Please go through this. Then your third step is to you need to check for the black shear failures. You need your third failure mode of failure is what? Black shear failures. You need to check for this. So here we given the formulas is there in page number 33. Page number 33. Here we have formulas. What is that? TDB equals to AVG into Fy by square root 3 gamma m naught plus 0.9 into ATN Fu by gamma ml. TDB and TDB equals to 0.9 AVN Fu by square root 3 gamma ml plus ATZ into Fy by gamma m naught. It should be greater than the factored loads. So factored load. So here also we have some terminologies. Here we will use we can check here. Here also we are using what is here we use some terminology AVZ, ATN, AVN and ATZ. ATN, ATZ, AVZ and AVN. So here let us take this example, guys, please. Let us take these examples. Here two examples you can consider. So example 1 and example 2. Example 1 and example 2. Yeah, is there in code book. Please go through the same explanation is there. So when you apply tension load, guys, please, when you apply tension load, this line may subjected to a tensions. So along these lines is subjected to a shear. So along these lines, so this line, shear line we call it as, along this line is subjected to a shear, and this perpendicular line is subjected to a tension. That's why this length is called LV. LV means shear length. LV means shear length. And this perpendicular distance here we subjected to a tension. So this region is subjected to a tension. That's why this distance is called LT. Please remember, what is that LT and LV? LV is shear line. When it's subjected to a tension force, so this line is subjected to a shear. So that's why LV, and this is LT. So if you have only one, here you can see two bolt lines. If you have only single bolt line, means this have only single bolt line, means here to here. This line is subjected to a shear. So you can see this line is subjected to a shear. This is shear lines, and this distance is subjected to a what? So here is subjected to, this is perpendicular to the applied load. This is LT. This distance is LT. This is C. What is C? Or WL? Maybe in the seconds mode of failures, there failure due to rupture. There I explained you what is that WL. W means from distance of between the first bolt line to the bottom of the connected leg. So bottom of connected leg, distance between first bolt line to the bottom of connected leg, that is taken as WL, that is C. So there is C here. So you can see these terminologies here. So where you can find this while doing problems, we will face this. Where you can find this, it is there in page number 168, SP6. SP6 steel handbook. In steel handbook they given the these distances, how much it is, they mention the distance. If it's two board line is there, so this is to here it is A, and here to here it is B. So then let us take this how to calculate AVG. AVG means what? Gross area parallel to the load. Gross area parallel to the load means this is the load I am acting. So parallel to this means LV into thickness of the plates we need to consider. So like this we need to calculate. What is the AVG? Gross area parallel to the load. How you to calculate? LV into T. LV means shear length. Shear length. Shear length. So this is the shear length. This is the shear length. LV into T. So then next terminology is I am using, what is that? AVN. This is what? Net area parallel to the load. Net area parallel to the load. How to calculate this net area parallel to the loads? So I can calculate by AVG. This is AVG minus bolt holes. How many number of the bolts in shear line? How many number of the bolts? How many number of the bolt holes are there in shear line? We need to deduct that one. That is what given here. How many number of the bolt holes are there in shear line? We need to deduct that one, minus bolt hole, minus bolt holes. Similarly here the given terminology ATG. ATG means gross area perpendicular to the load, means this is the load acting perpendicular to this, or here perpendicular to the load acting, perpendicular to load acting. This is what? LT into T. This is given LT into T. LT into T. Then what is ATN? That equals to what? Net area perpendicular to the load. That is how you have to calculate ATG minus bolt hole. ATG minus bolt hole. We need to do it. Means along the perpendicular line, how many number of the bolt holes are there? We need to deduct that one. So we need to deduct that one. Here also, how many number of the bolt holes are there? We need to deduct that one. Please remember this. Along this length, how many number of the bolt holes are come? Here also along LT, how many number of the bolt holes will come? We need to deduct that one. So please remember, this is how we need to calculate AVG, AVN, ATG and ATN. So then you need to check are the modes of the failures. It should be greater than the factor load. Then I can say whatever the selected sections from the steel table, it is safe. That's how we need to design tension members. Thank you guys.